Hi, welcome to the evolution of the web. The web's changed a lot since it first began. And today, when I think of the kinds of people creating content for the web, I often think of teams of highly skilled workers constantly adapting to an ever-changing landscape of tools, trends, devices, and technology. So given that technology and the web are changing so fast, it's not difficult to imagine the web of the future looking very different than the web we have today. And given that fact, what will the future of the web look like and how will we create content for it? By exploring how the web is changing and where it seems to be heading, and comparing this to examples outside of the web, I hope to shed some insight into these and other questions. So I'm CJ Gammon. I work at Adobe and I spend my time creating interactive experiences and applications focused on web technologies. And I think the web is an amazing platform that connects us globally, and it's difficult to imagine a future where we all aren't more connected because of the foundation of the web. So before I get started, I want to promote a little website that a friend of mine made, Alexis Taveria, called caniuse.com. And Caniuse is a great resource for browser compatibility charts, and it showcases what features are supported in which versions of the browser. And I bring this up because some of the features we may be talking about might not be widely supported everywhere yet, so you just want to make sure that the features you're using are supported on the platforms you're targeting. So if you remember back to 2012 at the Olympic Games opening ceremony, when Tim Berners-Lee, the creator of the World Wide Web, sat at a computer and typed in, "This is for everyone." It then sent out a tweet and also projected the words across the stadium. Now, if you think of the phrase, "this is for everyone," there's two ways to think about it. One is that this is for everyone to consume. The other is that it's for everyone to create. Now, given that the original web browser had a web editor built into it so that editing content for the web was on the same level as consuming it, I think it's safe to say that both were originally true. But creating content for the early web was really easy because the early web consisted of very simple documents that pretty much anyone could create. But over time, these documents and the kind of content we create on the web have gotten much more complex. And this is largely due to the web's competition with native platforms. So trying to emulate and recreate the experiences that people are used to within native applications. So because this content has gotten more and more complex, how do we then make sure that everyone can still create for it? How do we simplify the creation of this more complex content? Doing this would not only allow everyone to create the amazing content that the web is now capable of displaying, but also raise the bar for people pushing the web and push the platform even further. So this competition of web versus native was largely spawned off of the popularity of the mobile web and mobile application stores. So in this context, native applications had a huge advantage on mobile because on mobile you're typically dealing with weaker hardware and weaker devices. So these lower level APIs that are closer to hardware and give developers better access to the hardware allow them to optimize around the weaker hardware and create more amazing experiences. On the other hand, the browser is traditionally these higher level APIs that are very specific to web functionality, things like documents. So we don't often have access to these lower level APIs that allow us to do really amazing things on the hardware. But it's important for us to remember that these browsers that constrain the access we have to the hardware are simply a layer that lives on top of the native platform. So all we need is for the browser to give us access to these lower level APIs to be able to take advantage of the same features that native has. So one of the areas where native has had a huge advantage over the web has been performance. And performance as it pertains to user experience is the perceived smoothness of your application. For example, your site has good performance when a user interacts with your application and they get an immediate response and a smooth animation. Poor performance, on the other hand, is when a user interacts with it and there's high latency or jittery animation, so unexpected results. So rendering and animation on the web are traditionally done through software on the CPU. Now, the CPU is a piece of hardware within our devices that's the central processing unit, and this is responsible for all the application logic within our devices. And because of this, doing animation and rendering on it can get slow and cause poor performance. So let's take a look at what native does to overcome this. Well, native actually takes advantage of another piece of hardware within our devices, the GPU. The GPU is the graphics processing unit, and it's a specific piece of hardware that's intended specifically for graphics rendering and manipulating textures on the screen. Because it's specific to this task, it's really good at it and very performant. So to further illustrate the difference between these two pieces of hardware, I put together this simulation. Now, here we have an image, which is our Pac-Man ghost, that's made up of a bunch of pixels. This is going to represent a texture on the CPU. So what we're going to do is take our original image on the CPU and make a representation of him on the GPU. And we're going to do this because the GPU is really good at manipulating textures. We're going to take a photograph of him. And this photograph is going to represent our texture on the GPU. So now we're going to race these two images just to see which one's faster. So as these race back and forth, what you can see happening is that the GPU texture is moving really fast because it's taking this texture that it's retaining in memory and just updating its position on the screen. The CPU, on the other hand, has to work really hard and actually redraw the entire image at each new position. So while this is just a simulation, I think it really showcases how these two pieces of hardware have to work really differently to perform the same task. So here the GPU is obviously more performant and wins. How then do we leverage the GPU in the browser? Well, as I mentioned, the browser is this layer that sits on top of the native platform, so it can provide hooks into generating these textures on the GPU. And it's done this in CSS. So we can actually leverage the GPU with CSS. And this is what happens when we use CSS to create transitions or animations. So when we use transforms, opacity, or filters with transitions or animations in CSS, it's actually creating a texture on the GPU and using that to animate it so that you get really great performance. Now, occasionally on weaker devices, you can notice a flicker when you do this at the point at which you start to animate your content. And this has been an issue where this is the point at which we're actually converting a CPU texture to a GPU texture. So to avoid this sort of issue, developers discovered a hack that they could use to work around it. And what they're actually doing is utilizing the translate Z hack. And some of you may have seen this or used this before. And what it does is it's actually tricking the browser into thinking you're using this static image or texture element as a 3D element. So it's creating a GPU texture without you actually doing anything to it. So this allows you to smoothly transition from a static element to an animated element on the GPU without going from a CPU texture to a GPU texture. Now, obviously, this is a hack and not standardized, so this doesn't work the same across all browsers. So the W3C saw that people were doing this, and since we shouldn't have to resort to hacks in order to just make things work the way we want to, they created a standard approach to achieving this. And the standard approach is the will change property. So the will change property is a newer CSS property that allows you to specify which properties are likely to change within your element. And this allows the browser to optimize around that specific task, that specific property. So in some cases, it'll create a GPU texture without having animated it yet, just in anticipation of that change. So this is the standard approach to achieving this without resorting to hacks. You still want to be careful when using this. You don't want to overuse it because just like with the Translate Z hack, you can end up creating too many textures on the GPU, which especially on weaker devices can cause memory issues, which cause their own performance problems. So we've talked a bit about graphics already, but what if we want to get deeper into graphics? When we think about the kinds of things you can do on native platforms, you often think of really rich graphical applications where you can dynamically draw things with code. So on the web, we haven't really been able to do this. For a long time, we've had these high-level extras like CSS, which allows us to style our documents, and SVG, which is a vector language format for scalable vector graphics on the web, which work great at every screen size and resolution. But what about these lower-level APIs? What if we want a 2D drawing API on the web? Well, we can actually take a cue from native operating systems like OS X, which have core graphics. So core graphics is a 2D drawing API on OS X that allows you to draw 2D shapes and images. And the web community has actually adopted this into the 2D Canvas API. So the 2D Canvas API is modeled after core graphics for drawing 2D shapes and images right inside of our Canvas elements within our HTML documents. So now we have the ability to draw 2D shapes and images dynamically with code. But what if we want to go a little deeper? If we think of native applications, we often think of games and the kinds of rich, immersive experiences people are able to create with these lower-level APIs that they have on native platforms, where they're really able to take advantage of the GPU and the hardware that they have. So what if we want a lower-level graphics API for the web? Well, again, the web community took these cues from native platforms like OS X, which uses OpenGL. So OpenGL is a lower-level API that allows you to draw 3D or 2D shapes and textures. And this is really low level and allows you to do really amazing things. And the Kronos group who specified OpenGL took a version of OpenGL ES 2.0 for embedded systems, which is intended to work great even across weaker hardware. And they adopted it into WebGL. So WebGL is based off of OpenGL ES 2.0, and it allows us to leverage this API within our Canvas elements. So it's a JavaScript API modeled after OpenGL. So this allows us to do really rich 3D shapes and images and really amazing experiences right inside of our Canvas elements on the web. So you can imagine this brings some really cool things to the web. You can imagine AAA style games running right inside of your browser. Here's an example of a website that uses WebGL to do some pretty cool things. So we'll just wait a second for when it loads. What it's actually going to show is that they have this scene which is a 3D scene with a camera positioned in it and really rich textures and lighting effects. It also incorporates some cool effects like reflections. So here we'll see and the neat thing about it is it's actually interactive. So we can move the camera position around. And you'll see we've got these lights that are actually creating these reflections on the walls and surfaces as I move around, and also these rich textures on the walls. So I think this goes to show how it's a really powerful tool to create some really amazing experiences right inside of your browser without the user having to install anything, just by navigating to a link. But with all these great experiences and all this great power comes great complexity. WebGL isn't easy, and it's a very low-level API that involves understanding of some complex concepts like shaders, buffers, and memory management on the GPU. So here's an example of some WebGL code. And I don't expect you to read this because it's very tiny, but the point I'm trying to make is this is a decent chunk of code. It's a little over 100 lines of code, which in the grand scheme of things really isn't that much. But if you take a look at what this actually creates, it's this. We have a white square inside of a black canvas element. So this is a black canvas element drawing a white square, and we did this with over 100 lines of code just to get this up and running. So you can imagine how this would scale up into a larger application that, imagine a fully interactive 3D game with models and textures and all these other things that are involved in that, and how much code it would involve to create that. It would really blow up. And so I think it's important that we realize what goes into this, and how each time we would build something, we'd essentially be building a whole new framework just to get up and running. So let's simplify it. Again, the web community can look at native platforms and what they've done with these more complex APIs, and they've actually built communities of frameworks. So they have these great frameworks that abstract these complex APIs so that developers can build applications more quickly and focus on what it is they're building. So the web community has done the same thing, and there are a bunch of great WebGL frameworks out there. One of the most popular ones is Three.js. So here's an example of a Three.js application, and you can see here it's a little over 10 lines of code. So literally like 10% of the code we were doing before. And if we go through it line by line, you'll actually see some concepts that are really similar to a 3D application. So here, for example, we're actually building our scene, which is where all our objects are going to live. Then we can create a camera, which has a specific perspective and aspect ratio. And then we can create lighting. So we can add a light to our scene relatively easily. And then in this bit of code here, I'm just creating a mesh that takes specific geometry and material and adds that to our scene. So if we take a look at what this code generates, it creates this, a 3D rotating cube. And while this isn't the most impressive demo, I want you to remember that this was created with just a little over 10 lines of code, and compare that to our over 100 line of code example that created a square. You can see it really allows you to focus on what it is you're building and really not have to worry about all the boilerplate code that goes into building this lower level application. So if you're interested in getting started with Three.js, one of the best ways to do it is just by downloading the source code on GitHub. So you can download the library, and it's bundled with a bunch of amazing examples that go through literally every kind of use case you would want to use the framework for. And each one of them you can go through and actually view the source of how they did it. So you can see some really cool examples, and really just kind of go through and pick out and figure out what it is you want to do and see how they achieve that within the framework. So here's an example of one of the demos they have bundled, and you can see they're really robust. They have really rich textures and animated models, and even cool post-processing effects like blur and depth of field blur being applied. So you can go in and see exactly how they did this with all the assets included. So we talked a lot about the hardware as it pertains to rendering content onto the screen, but I want to talk a little bit about the other kinds of hardware we have within our devices. If we think about all our devices today, they're very different from the devices we had when the web first started. For example, we have things like cameras, GPS, lights, all built into our devices. And that's not even getting to the kinds of peripherals that we can plug into our devices to add even more functionality. And the web's getting really good at being able to access this kind of data. So, for example, we can access the webcam data. Here I'm actually just pulling in the content from the pixel data from my webcam and drawing it back onto the screen as circles into a canvas element. So you can create some really interesting visual effects using the user's webcam data, and even create really practical applications utilizing this within your web apps. We're also getting some cool new APIs like the Gamepad API, which allows us to access gamepads right within the web browser. So we're used to seeing casual games and other kinds of simple keyboard and mouse-based games within the web, but now we can actually access the gamepads and be able to create some really cool applications and games much more like native gaming experiences. So people being able to use the gamepad for things like platform games and other cool action style games right inside of the browser. And this is really amplified with when you combine it with concepts with what we have available in Canvas, 2D Canvas, and WebGL. We're also seeing some new kinds of interaction models come up that are kind of experimenting with how users interface with computers. And one of those is the Leap Motion device. So the Leap Motion device is a device that you plug in and actually lets you interact with software using your hands. So you can use gestures much like you would on a touch device, but without actually touching anything. So this is a pretty cool and experimental way to kind of see how people can play with software. And because of this, they didn't want to wait around for the W3C and the browser vendors to implement it natively. So what they did was they actually released a JavaScript library that you can use today and use in your web applications so that you can integrate the device with it so people can use it right out of the box with your web content. So this is a great example of them taking the initiative and really allowing developers to use their hardware within their applications without the vendors and the W3C having to implement it. So I have an example of an application I created that kind of shows you how you can use this in a fun way. So here's a little VJ video player application I have, and if you look at the bottom, there's actually a color swatches down there. And what it does is when I swipe with my hand, it actually goes through the different swatches that are being applied to this video. And I can use different gestures. For example, I can draw a circle that shuffles the colors and the order that they're being applied to the content. So I think this is just kind of a fun little live VJ application. You can imagine someone like up there kind of waving their hands across the screen without actually touching anything, changing the colors and manipulating the content that's being displayed. So we've talked a lot about web and native and their relationship to each other, but I think it's important for us to realize that while the web's continuing to get closer and closer to native and a lot more native-like features, we really can't ever be without native. We still need this underlying platform for it to live on top of. And that's okay. It's important for us to remember that these two have a relationship and they're not completely independent of each other. And we can even mix and match different parts of each of them. For example, we can write native shells that host web applications and deploy those natively to the different native app stores. Now, doing this across all the platforms can be really tedious, but there are great communities out there like PhoneGap with communities of great plugins that allow you to deploy your applications across all the different platforms relatively easily, all using the web APIs and foundations that you love. So it's important for us to remember that we need to be agnostic about our technology and make sure that we're using the best tool for the job. So I want to talk a little bit about virtual reality because I feel like I can't talk about the future of the web and where things are headed without mentioning virtual reality. And virtual reality is where we take ourselves and utilizing these headsets, put ourselves inside of a virtual world. And this has gotten really popular with the success that's been around Oculus Rift. And we're even seeing other players like Google and many others getting involved in creating these headsets that essentially allow you to mount your phone to your face using your phone and its orientation data as the virtual reality headset. So they're really trying to get it so that people aren't limited by not having these more expensive headsets and can just utilize their phone to create these amazing experiences. And the way that this is achieved is through a stereoscopic view. So a stereoscopic view is where we actually take our single view and split it up into two viewports. And this is largely based on how we have two eyes with two different viewports. So if you've ever used a magic eye or a stereogram, where you have these patterns and you stare at them for a while and eventually you start to see a 3D image pop out, you can understand how your brain is easily tricked into seeing 3D shapes and this perception of depth. And this is exactly how a stereoscopic view works. It takes these two separate viewports and your brain merges them together to create this illusion of depth. So we can actually create a stereoscopic rendering in WebGL, and 3JS actually has a library that allows you to do this that's packaged with their examples. But we also need access to the headset data. For example, as I move my head around, I want to be able to update my application and the camera that it's using to position it within the scene. So this is where the WebVR API comes in. And this is being developed by the W3C to allow us to access the headset data and orientation data so that we can update our applications. And Mozilla has actually some really cool examples. They've been doing a lot of research, the Mozilla VR team. So go to mozvr.com, mozvr.com. If you want to check out some cool examples of the kind of demos that they're doing around VR and the web, and it goes beyond just WebGL game-like experiences. They're actually exploring different ways that users can create with traditional web experiences like documents inside a VR headset. So there's some cool stuff going on there. So augmented reality, on the other hand, it is sort of the cousin of virtual reality. So where virtual reality is us placing ourselves inside of a virtual world, augmented reality is us taking these virtual things and placing them in our world. And this has actually been around on the web for a while in sort of a gimmicky way. So if you've ever seen, this used to be a Flash plugin called the Flower Toolkit, but they've adopted it to JavaScript. So the JSAR toolkit allows you to basically map these 3D shapes and content to a marker so that you can manipulate them. So here I have a little cupcake I made in 3D that's being mapped to this marker. And as I move the marker, the cupcake continues to move. So this is kind of gimmicky, and this and things like facial recognition and facial tracking have kind of been the extent of augmented reality that we've had on the web. But if you've been paying attention to Microsoft and their announcement they had at their developer conference recently, they announced a HoloLens project, which shows using augmented reality in combination with this headset concept, where we're actually mapping these holographic images to our 3D world in space, which I think shows some really amazing examples that are really practical as far as how people are going to work with these augmented reality experiences. But I think it also poses a lot of questions, such as how are we going to create content for this through the web? What's the web's relationship going to be with these kinds of experiences, if this is the future of how we're going to interact with digital media? So given that we have all these cool headsets and experiences, where is this all going? What kind of web experiences can we hope to see in the future? Well, today when I go someplace, I'll often check it out first on Google Maps in Street View just to get an idea of the area. And you can see here with Street View, we have this 360-degree view, and this is consisting of a bunch of photo-stitched images that are all stitched together to create this view. And while this is cool, what if in the future, instead of just viewing images, what if it's video? What if we can actually see 360-degree video within these virtual reality headsets? And what if we have a drone that we could actually fly around in real time to explore all of the world? Now, obviously, there are probably some logistical issues here, but if you think this sounds like science fiction, Google is actually working virtual reality into Google Maps already. So if you have Google Cardboard, or if you have an Android phone, you can actually go into Street View and use a virtual reality view for Street View. And while it still just uses the photo stitched image version that's static, I think it would be really amazing if we could open this up to to video. So we've talked about animation and how we can get better animation performance utilizing the GPU through CSS. We've talked about graphics and the amazing kinds of graphical experiences we can create with 2D Canvas and WebGL. And we've also talked about the peripherals and the other kinds of hardware that we can access now through web APIs. And this is all made simpler and more powerful due to the power of libraries. So these libraries really make it more efficient and give us the ability to build things faster and better with all these complex features. But libraries are just code, and code's very specific to developers. So it allows developers to take advantage of these more complex features. But what about designers? How do designers create content or create designs for these more complex experiences? And if we think of designers, they're very visual and they create visual content, and they need to do this in a very visual way. So if we think of the kinds of tools that designers are usually involved with, they're often very visual tools with rich graphical user interfaces that allow them to work efficiently in their medium. So if we take a look at the kinds of workflows that the top people in the industries, in the most complex technical industries, have, what they're actually doing when they're pushing their medium forward is building their own tools. And this allows them to be really efficient at what they're doing and optimize around their specific needs. So we can actually do this on the web. So here's an example of the presentation I did last year here at South by Southwest, where I'm actually flying through this 3D scene. And you can see I have a camera that's mapped to a specific path here. And the way I achieved this was actually creating my own tool. So here's a little tool I made. And you'll see here the way it works is I can actually just create this path, this 3D path in space. And if I go through and add, I can load my scene into it so that I can actually see where the camera is in space. So here's my camera moving around the path, and down here you can actually see what it's seeing. So you can see the camera's view. And this allows me to sort of move these nodes around and really figure out where I want to position my content in space. So this allowed me to map out the camera on an exact path and trajectory that I wanted. Well, this is a great example of me building a tool so I could do something visually in a visual way. We're not always going to build our own tools from scratch. But what if we can tap into the tools that designers are already using? For example, 3D is a really complex workflow, and 3D designers and animators have to understand these really complex tools. For example, this is Blender, and you can see it has a really complex UI that people that take the time to learn it really want to stick with their application and invest a lot of time into understanding how it works. So here I actually used Blender to create this 3D model, and I animated it so you can see his arms are moving. And what we can do is actually have an export workflow with 3JS. So 3JS actually comes with a 3JS plugin for Blender that allows you to export a JSON file. So I just go File, Export, and I can export my model and then load it into my 3JS scene. So here I have my model inside of 3JS, and I'm just able to use code then to like animate him around the scene in interesting ways. So you can see here we can create some really amazing workflows where designers who are really great in 3D programs can utilize their experience and expertise there and then simply export their content for a developer to use with code and be able to load that into the library and manipulate it. But what about other kinds of tools? For example, Photoshop. A lot of designers use Photoshop for rich image editing. And we can actually tap into Photoshop in much the same way. We can actually write scripts inside of Photoshop. So Photoshop has this feature called Generator, which is essentially a node server running inside of Photoshop. So this means that developers can write JavaScript that actually taps into the Photoshop application, giving them access to things like layers and information about those layers, but also responding to events within the application. So I have an example of how we can use this. We did a project with PBS Kids. They have this comic book called Word Girl. And it was this comic book that they gave us that they wanted converted into a web experience. So they gave us a PDF of this comic that consisted of about 70 frames. And because we were bringing it to the web, we wanted to make it a little more engaging and interactive. So we broke up all these frames into separate layers so that we could animate them. So it ended up being about 200 some layers. Now, as you can imagine, it would be tedious to go through all these layers and save them out for the web layer by layer. You'd have to copy each layer, open up a new file, crop it to size, and then do save for web. So instead, what we did was we actually wrote a script that automated this process and went through all the layers and saved them out as optimized web files cropped to size already. So not only that, we were able to access other information and collect it into a JSON file that we saved out. So we had a JSON file that basically represented our whole PSD, such as the position of the layers within the document. And this allowed us to create our Word Girl application. So here we have Word Girl, and you can see we have all these things laid out exactly as they were within the PSD. And we were even able to collect other data. So if you'll notice as I go through it and the images are animating outside of the frame, they're being clipped to that frame. So we had vector mass data that we collected into the JSON file that allowed us to clip the images to the frame so that when they go outside of the frame, you're not seeing the image still. So we can collect all that cool data, but not only that, we can create some really amazing workflows too. Because Generator responds to events, here I have the PSD open. So what I can do is I can actually go in and edit it. And if I go back and refresh the application when it's not cached, you'll see it updates right away. And I can go back in, make more edits, and go back in and immediately see that change. So here you can see we can have some really amazing workflows where Photoshop is actually just recognizing that that layer has been updated and saving out a new file, that one file for that layer that's been changed, and putting it in the place that I've specified. So we can have some really amazing workflows and custom workflows for an application where designers can continue to work in the tools that they're used to and then not even have to have this handoff process. Designers automatically get pushed the updates from the designer. So I think that can show the possibilities of some really amazing workflows between designers and developers using these kinds of features. But what about other kinds of workflows? For example, animation. If anybody remembers this guy, this is Homestar Runner. So if you were into the web back in the early 2000s, you've probably seen Homestar Runner at some point, but it was a popular Flash cartoon on the web. And these kinds of things were all over the place at that time because it was really easy for designers to build these rich animations and really cool animations within the Flash animation tool. And if you think about it, like these kinds of experiences have kind of disappeared from the web. And when we think about it, cartoons that we have today, like South Park, probably might not even be where they are today without the simple ability for designers to create and animate their ideas with tools like Flash. But beyond that, even today, Flash is used for children's cartoon shows. So my daughter loves Daniel Tiger's Neighborhood. And they actually use Flash for the animation within Daniel's Tiger Neighborhood. So it's this mature animation tool that's even used today for television cartoons. So what if we want to take this mature animation tool and export animation content for any platform? Well, we can actually do that today with Flash custom platforms. So Flash custom platforms allow you to write plugins for the Flash animation tool to export to any platform. And there are already plugins for today for things like Canvas and WebGL. But not only can we target these APIs, but we can also target specific frameworks. So if your developers have a specific framework they like, then developers can write their own plugins for Flash targeting their framework or workflow, or even however it is they like to export data from this animation tool. So I have an example of a plugin that I made in Flash. So I wrote a plugin for SVG. You can see here we have our Canvas, WebGL, and we can also target our custom plugin that I created for Snap SVG. So this is utilizing the Snap SVG library and exports SVG content to the web. So I already have one open that I'm going to show you, but here's my little animation of this bouncing ball, and then it sort of slices open. And what I can do is simply publish that, and it opens up right inside of the browser. And then if we inspect this, you'll see that this is all SVG content. So I have SVG content animating inside of the browser from Flash. So I think this is pretty cool, and we can even go back into the tool and, for example, if we want to go into our timeline here and update it so that this scales down and maybe rotates, we can do it all visually, right? So we can see, preview, and hear exactly how it's going to animate, and then simply publish it to the format that we specified using our plugin. So here we can see we have that updated animation running right inside of the browser utilizing SVG. So we have these SVG elements moving around inside the browser. And this isn't just like SVG sprite sheets, it's actually updating the position of these elements within SVG. So I think this is a really powerful tool because it gives us control over how things are coming out of this designer application that designers are comfortable and like using and are able to animate things visually. And then developers are able to take that content and integrate it in their development environments the way that they want to. So I think it's important for us to remember that while libraries are amazing and we need this robust community of libraries to simplify the way that we're building these applications, we also need tools, and designers need amazing tools and workflows between designers and developers to really simplify the complex nature of what it is they're building. So that's it for me. You can check out all the source code for this at bit.ly SXWeb 2015. So all this stuff is open source. There you'll find links from the site. You'll find all the slides and their content, as well as my Flash plugin that you can check out. So thanks.